Okay, today I want to talk about going from a schematic in OrCAD to a PCB layout in OrCAD. Unfortunately, this is a fairly bumpy start because every single user who uses OrCAD has their own configuration file. And in fact, we can even see right here, it's telling us where that configuration file is. Actually run by typing in command, and I'm going to enter into that directory. So cd, c, user, cbrigs, app data, roaming, spb data, cds setup. I got a typo, let's see, roaming. So you can use the tabs key even in Windows to complete a path name. So OrCAD tab, 16.6 tab, and now to edit this file, notepad, capture INI. And what I see here is that by default is looking, here's that Allegro footprints section. So if we do have to create our own symbols, I like to keep track of my own outside of this directory, because this directory will get replaced whenever we do any type of OrCAD upgrade. And so instead, I like to keep my own symbols on my own PC outside of the OrCAD directory entirely. In fact, I have a project folder here called OrCAD that's in my C root. I own it. And in here are a pile of different folders that I use to hold my OrCAD projects in there. So inside here is my PCB symbols, and so here are all the different symbols that I've created over the years for whatever projects that I work on. I've got a lot of symbols. And so that's going to be C:\/ OrCAD PCB symbols. So over here, I'm going back to the capture configuration and capture.ini file. And I'm going to insert here a new dir0 to be C:\/ OrCAD PCB symbols. And then my dir1 is going to be the Cadence SPB 16.6. The reason why I do this is so that if I make a change to a built-in OrCAD symbol, mine comes first. So once we've made that change, I'll save that change. So now that you've made changes to the OrCAD capture INI file, we need to talk a little bit about how OrCAD manages footprints. Footprints hold the physical dimensions of the part on the board, and they define the shape of holes, the spacing around the part, and you can even associate a three-dimensional image of the part so that you can render your board in 3D. The way it does this is the OrCAD capture libraries that we use in Capture hold the schematic symbol, and one of the properties that we'll see in a moment is we can associate the name of a drawing file, which is the footprint. The footprint is composed of pads, and the pads define the holes and the contacts, whereas the drawing defines the composite shape. So, for example, we can scroll through some of these. We'll find a part that, for instance, here's an RJ45 connector. Defines the shape of what this connector would look like on the board. So this connector has 8 pins, and the shape of these pins are all defined by a pad. So we have the RJ45 3mm square pad for the mounting holes, or the mounting pads up here, and then these are the actual contacts. And we see that they're the A2014 whatever pad that is. So these are all stored in DRA files, so drawing files. And if we were to find in the OrCAD library, we could actually find where this part is used. And we'd see that the symbol has this name as its footprint. Okay. So that's the beginning of working with footprints. We're going to come back to that more in a moment. Let's go ahead and tackle some of the easy ones first. So I have a pile of resistors that are in this design, and I know if I were to look at my PCB symbols, my own, I actually have created footprints for all of the surface mount resistors that we use here in the lab. And they're all listed as SMD for a surface mount device, in either cap, diode, Pol cap is a cap with polarity, or a resistor. And I have all of the different sizes from 0402, 0603, and 1206. 1206 is what I recommend, especially for students starting out with their first board. So SMD Res 1206 is a footprint. It's not specifying a specific resistor value. That comes from the actual property here in the part. So we can go ahead and pick each of these. Alright, so we'll just go ahead and grab those. So I'll do these three. And if I scroll down here, the default footprint is an AX-RC05. I'm not sure exactly what that is. It's an SMD Res 1206. It's really the part number that I want to use for all of my resistors. So we can save that. Now I can go back and I can do the same thing to these resistors. So now I've assigned footprints to those. I have a couple more resistors over here. We can do these real quick. So that takes care of the 9 resistors that are on the board. The next thing I've got to deal with are these MOSFETs. And the problem with these MOSFETs are, these MOSFETs, if we have to pick a MOSFET. So, picking a resistor, typically these are going to be, 1/8 watt resistor. We're not using that much current, so there's typically no problem using these small little surface mount devices. These MOSFETs are going to be very, very specific to a particular motor application. So part selection is kind of beyond the scope of what we're after here, but what we can do with part selection is we can go into, say, the DigiKey website, and we can do a search for MOSFETs, and we can find a MOSFET that we think is going to meet our needs. And most importantly, we're going to want to keep track of the data sheet. And in fact, in many cases, you're going to want to keep all the data sheets for all of your parts, either printed or electronically, so that if the data sheet ever becomes unavailable on the internet for whatever reason, you have a permanent record of what the part is. So at this point, what we see here is the internal diagram for how the part should be wired. And we see that this guy uses pin 1 and pin 3, doesn't seem to use pin 2, but does use this tab. I would imagine, in all probability, even though it's not on the data sheet, that pin 2 is also connected to the tab internally. That's kind of typically what they do. But we need to make sure that when we bring this part over to a footprint, that the gate is on pin 1, the source is on pin 3, and the drain is on the tab and probably pin 2. I would want to actually have one of these parts to verify it. So if I look at this, if we look at the part itself, I right-click on this part and do Edit Part, and it's not showing me the part numbers, but by clicking on the pin, it says this is number 0, this is number 1, this is number 2. So these part numbers don't match. Of course, this is also the P-type. Discard. These parts don't match what the footprint that I've chosen. So I'm going to have to make my own part. But the good news is we can copy. And what we can do now is we can make a new part. And so what I'll do is I'll go to the libraries, and these are all in the ORCAD directory, which you can't change. But you can add your own. I've done that. I have my own stored in my ORCAD directory. So under ORCAD, under Capture Libs, I have my Briggs library. This was the same library that we used to bring in the custom title block. And in this directory, I can make a new part, and we can call this new part a MOSFET, but we probably want to name it something, for instance, based on its actual part number. And as a MOSFET, we'll put in, it's a FET, and here in the PCB footprint, this is where we can maybe connect it to this TO package that we saw. I see from the datasheet that it's a TO220 package. TO220 is a fairly standard package from a company called JEDEC, who kind of maintains the standards for these. And we were using, if I go back over here to my definition, a TO220H. Over here we do TO220H. We have to make sure that the name matches exactly. TO220H. And now we can say OK. And in the picture now, remember I copied the structure for the MOSFET. So this was the original version of the MOSFET. I'm going to change this now to be STP. Oh, I forgot the name again. I apologize, you guys. This is getting old. STP16N F06. So that's the part number. And this was our gate, and the gate was on pin 1. This is our source, and if we go back to our data sheet to verify, of course you guys probably remember that too, our source was listed as being on pin 3. And then our drain here was actually either on 2 or on 4. And I know that was 2 or 4 because that's what it's listed up as in here. So honestly, what we really need to do is have 2 of these. We can't have it be the same part, our pin name, so this would be D tab. Okay. All right, so at this point now we have made a new part. It's in the Briggs library. I can now go and delete my 4 MOSFETs that were down here. And if I go to place, I hit the P key to bring up the place option. I can now search the ST. So I can use wildcard matching, and there's our STP16. And I can now place this guy here into my design. So now we can try to put the new part in place, and it looks like we're going to still have the same problem. So maybe what we need to do is connect them up without the grid spacing turned on, since they don't quite match. We're going to have the same issue here with the drains. We need to make sure that they're connected. Okay, to kind of speed this along a little bit, I'm just going to actually make this kind of a broken circuit. I'm going to go ahead and just get rid of these guys, just as a proof of concept. You get the idea that it takes a little bit of effort to design a circuit. So we're just going to connect these down in a way that doesn't really make sense anymore, but at least it gets us to the point where we can make some progress. Okay, so I have over here that I need a connector for each of these guys, and again, if I go back to my OrCAD directory, let's see if we see anything up here in the con folder, or cons, or the jumpers. Probably the most likely place to see those. So as I keep scrolling up through here, oh, there's so many. I can find. Don't see any cons. But we can find and no jumpers. If I go back maybe to, so now what we can do is we can make our own. So I can now go here to the PCB Allegro tool, and you can just run this from Windows. But I want to make a new, I'm not going to make any changes, I'm going to make a new package symbol, and I can't create folders in that C-colon directory, or the PCB directory, but I can put it in mine. So I'm going to go here to OrCAD, and I'm going to make a new symbol, and I'm going to call it Con3. Oops, I already have one, but we'll go ahead and call it Con3A. And what I want to be able to do here is make a single inline package, and I'm going to click on Load Template. And I prefer to do things in millimeters, but perhaps you want to do things on your own. This is going to be a connector, so its reference designator will be C. I'm sorry, it'll be J. And I would need 3 pins. I want them spaced 2.54 millimeters apart. That's 1/10 of an inch. Maybe we'll make it 5 millimeters apart. We'll make it a little bit larger of a connector since they're bigger pins. The package width itself might be 5.5 millimeters, and the length, if they're spaced 15, probably 17 millimeters apart. Now, one of the things OrCAD does is it separates the definition of the part from the definitions of its pins. So at this point, I need to design some pad stacks in order for each of these holes. And so I can now run the pad designer. And what I'm going to do is I want to make sure that when I write a file, it's going to go here to OrCAD PCB symbols. And we're going to make a new. And we're going to call it Con3A pad. And I need a drill. First we'll make sure we're back into millimeters. I need a drill that's going to be, say, 1.6 millimeters in diameter. And under the Layers tab, I need to define how the copper will be around that drill. So that's the pad. And so, for instance, on the top layer, I want to circle that 2 millimeters, maybe 2.2 millimeters, because these will be higher current. So if there's an internal layer, we'll make it a 2.2 millimeter hole. And if there's a bottom layer, we'll make it a 2.2 millimeter hole. The solder mask is how much of the area do you want to keep exposed to copper. In other words, you want to mask the solder resist. We don't want solder mask, the green coating, to cover up things. And so we're going to make that a little bit bigger than the actual copper itself, so there's a little bit of margin. So 2.3 is great. And we'll do that on the top and bottom. So the solder mask, again, would allow the copper to be exposed as the annulus around the hole. And that way when you put a pin through it, you can solder the pin to the hole. And so now if I were to save this design, it says drill hole is defined but no symbol. And so I need to go back to the first panel here, and we need to make a symbol for the size of the drill. So 2.2. 2.2. And now if I save. So that was Con3A pad. And so now here I can do Con3A pad. And when I click on next, OrCAD's wizard will actually build this connector for me, and it shows the 3 holes that I've made, and it shows the space around it that's been reserved, and then this is the size of the connector that we've chosen. We have pin 1, pin 2, pin 3. If I wanted to make any manual adjustments, for instance, maybe I wanted to move a pin manually, I could do that. I'm just going to go ahead and click yes to save it. And over here, get rid of this. If I go all the way back to this connector, now I can come in here and say this footprint is Con3A. In fact, I can go back to... So I believe at this point we have assigned everything that needs to be assigned to the PCB footprint. I do see one thing that we didn't do is we didn't put power and ground on a connector. Oh, no, there they are. So power and ground. The fact that these nets have the same names, they're all connected. So at this point we're ready to export this design. And so what I need to do is close this page. And on the schematic here, what I can do is to create a net list. This is the first step to being able to export to OrCAD. And so I create the net list, and the symbol that, or the PCB property that holds the footprint definition is PCB footprint. I want to create a blank board that's going to go into the Allegro subdirectory of my project, and it's going to be called motor controller. And yes, I want to create all that. And if there are any errors, we'll see errors. And generally where you get errors because we're missing footprints or I couldn't find them. I get a warning, but I don't get any errors. So the next step we can do very quickly here is we can place components. So I do that manually. and it's just a matter now of placing the components onto the board that you want. And you can put them where you want. Okay, so that J contour is not defined. I thought it was. We'll have to go back and define that. But I can place the rest of these guys onto the board. And it doesn't look like the FET was found. So that's kind of curious. So we'd have to go back in and find the parts and make sure that they're there. One of the things that you have to do with OrCAD Allegro is, just like we had to tell Capture where to look for footprints, we have to tell Allegro where to look for footprints. And we do that here by going to User Setup, User Preferences, and go to Paths. And under Paths we can go to Library, and you have to click on every one of these and make sure that OrCAD PCB symbols, or wherever you're storing your local symbols, your personal symbols, is listed in every one of these directories. I have done that for mine. You'll need to do that for yours. Alright, so at this point we have the board, we have the parts on the board, some of them. I can now make an outline for the board and give the board a shape. 400 mils is actually almost an inch. That would be an inch of board margin. We typically don't need that much. And so I make it 40 and pick the board size I want. And at this point you can go in and lay the board out. You can move parts around. And when you're ready, you can actually go ahead and connect these guys. Before I do that though, one important step that you always need to do is to go here to Setup and go to Constraints. And one of the files that you can check out from my SVM library is a technology file. And here in OrCAD LPKF 16.6 TCF, this is the technology file for using our equipment. And it sets like the minimum sizes for things. If you don't do this, by default, OrCAD will make a board that you can't produce with our equipment. One of the neat things you can kind of start with is we can do a step called auto route. And what auto route allows you to do is to let the software do the routing for you. And it will look for the best way to connect all the components. But be warned, you'll need to go in maybe and make some adjustments. And to do that, you would need to use the tools over here. For instance, maybe I want to slide the path out of the way. The auto router just seems to make some really terrible decisions sometimes, and it's kind of hard to predict what it's going to do. You know, I'm looking at this, and those are really close together, and while the machine might be able to build that circuit, why not make it easier and less error prone? You know, why did it need to put that right there? You know, maybe we could move that via somewhere else. So we'll talk about some more of these issues. This is really just to kind of get you started. Once you have the board kind of ready to go, you can then export the design. That's a different video.